Thank you for checking out A1 Math, and today we're looking at compound interest and Half-Life. So let's begin. All right, so before I go into compound interest and the pieces that you need for that particular formula, what I want to do is talk about um, a little bit about what compound interest means. Basically, normally when we do just regular exponential functions, we're talking about how it multiplies or compounds every year. Okay, but sometimes things those the interest doesn't accrue every year. Sometimes they accrue every year as annually, or it may be quarterly, or it may be monthly. And when that happens, you're going to plug in a different number into our regular growth or decay formula. So if it's um, annual, you're going to put 1 for n. If it's quarterly, you're going to put 4 for n. And if it's monthly, you're going to put 12 for n. So let's take a look at a few examples. All right, so first we want to talk about the formula, which is A is equal to P times 1 plus R over N raised to the NT. And it seems like a whole lot of stuff, but it's not, okay? The P is representing the original amount. It's called the principal. And it's the same thing as the A is in our regular exponential growth formula. The R is the interest rate, the exact same interest rate it was in the previous formula. And the A is the total balance after T years, after however many years. And T is the number of years. So basically, everything that we had before is the same thing. The only thing that's new is the N, okay? And N is the number of times the interest is compounded in 1 year. So when do we look and add more money to the original amount, okay? So I'm going to show you how to put that into the formula, okay? So the first thing you want to do is read the problem and determine which piece is which. So I'm going to start off and I'm going to list everything here. I need to know what the principal is. I need to know what the rate is. I need to know what the n is. And I need to know what the time is. So these are the things I need to know. All right, so it says write a compound interest function to model $15,000 invested at a rate of 3% compounded quarterly. Then find the balance after 8 years. All right, so what I have here is the principal, and the principal is 1,500. So that's what I begin with. And the rate is 3%. I'm going to go ahead and convert that by moving the decimal 2 places. That's going to be 0.03. And the n, I could determine that based on the fact that it's compounded quarterly. All right, and if it's compounded quarterly, that means it's 4, so 4 times a year. So I'm put 4 in for n, and the time is 8 years. All right, now I'm going to write all of this out into the formula, everything but A. So A is equal to the P, which is 15. Actually, I need an extra 0 here, 15,000. All right, open parentheses, 1 plus the rate, which is 0.03, divided by the n, which is 4. And we're going to raise that to the n, which is the same 4, times 8, which is the time. And I'm going to put this in parentheses as well. All right, now I'm going to type all of this in the calculator to get my answer. All right, I want to use this calculator. So let me go back here. All right, so I'm going to type all of that into the formula. So I got 1,500, 15,000. All right, open parentheses, have 1 plus, and this is a fraction. So there's a couple ways to do it. On this calculator, I'm going to hit this button here and just type it in. 0.03, tab down, and type 4. All right, then tab on over, close parentheses. Okay. Now, on some calculators, it has a button like this. And what you would do is you'll do the first part of parentheses. When you get to the fraction, you'll put 0.03, then that A, B over C button, and then hit 4, and then close parentheses. Now we're going to raise it up to the n times t, or the 4 times 8. And I'm going to put that in parentheses. 4 times 8. And then close parentheses. And then just hit equal. Alright, so the answer I get is, let me see where I can write that. Erase this here. Put A is equal to 19,051.67. So 19051 and 67 cents. And it's my final answer. Alright, so again, you want to make sure you find your P, your R, your N, your T, and just plug them into the formula. Alright, now take a look at these 5 and 6 here. And remember, you want to start off with your P, your R, your N, and your T, and plug them into that formula, which is A is equal to P times 1 plus R over N times NT. All right, here we go. So once you work this out, you end up with, for the first one here, $20,298.89, and for the second one, $26,979.99. Okay, so you just plug it into your formula. The principal is 17,000. The rate 3%. Annually is 1. N is 1, and T is 6 years. So I plug those pieces in the right spot there. Now, when it's 1 year, or annually, I should say, when it's done annually, you do not have to plug this in, that 1. That's only necessary when it's not annual, because then it's just a regular growth formula. Because 1 times 6 is going to get you 6, and 0.03 divided by 1 is going to get you 0.03. So those numbers don't change. But on quarterly, you're going to plug in 4. Okay, and don't forget to put this in parentheses. All right, now let's take a look at Half-Life. Okay, so with Half-Life, more often than not, we're talking about some type of substance, and it decays over time. So um, basically, your main formula is A is equal to P times 0.5 raised to the T, and the 0.5 is the half-life. Okay, so remember the P is going to be your original amount, the A is the final amount, and the T is the number of half-lives in a given time period. So, in order to figure that out, this is what you want to do. Uh, you want to let's take a look at the first example, okay? So it says Ismuth 212 has a half-life of approximately 60 seconds. It says find the amount of Ismuth 212 left from a 25-gram sample after 300 seconds. So all you need to do, all right, so now we got A is equal to P times 0.5 raised to the T. And what we have to do is find the P and the T. Those are the only two things we need to find. So P is going to be what we start off, the original amount. So the original amount here is that it starts with 25 grams, so P is 25. All right, now we got to find the T. So the T is the number of half-lives in a given time period. So to find that, we know that we get a half-life every 60 seconds. And they want to know what happens after 300 seconds, how many half-lives that's going to be. So to find that amount, you're going to take the 300 and divide it by 60. And that means you'll have 5 half-lives. So in the time period of 300 seconds, it's going to have a half-life every 60 of them. So how many is that? That's 5. So now you got to do is just plug the 5 and the 25 into the formula. You have A is equal to P, which is 25, times 0.5 raised to the T, which is 5. And then you type that in the calculator, and you get 0.78125. All right, let's take a look at a couple more. Go ahead and try with these two here. So remember, you need to find your original amount, which would be, in this case, 30 grams. That's your P. Change colors here. So this is P. And then the half-life, you want to find your T, which would be the 24 divided by 8. And that'll get you your T, and you plug that into your formula, which is A is equal to P times 0.5 raised to the T. So take a look at this one and see if you can solve this one. All right, so this is what we got here on this one. So the half-life on the first example with 30 grams is our principal, and the time, 24 divided by 8 is 3. We plug in that T, that's the number of half-lives we have. So we got 30 times 0.5 raised to the 3, and that's going to get you 3.75. All right, on the next one here, we've got 40 grams of sodium 24, and it has a half-life of 15 hours. How much will it be in 60 hours? So you're going to take the 60 and divide it by 15, and you get 4. So we plug in the P, which is 40. 0.5 is for the formula, and we plug in 4 for T. Type that in, and you get 2.5. And that is how you do exponential growth or decay as far as a compound interest and for a half-life. I want to thank you for checking out A1 Math. Have a nice day.